All right, welcome to lesson 35. This lesson pretty much just is a continuation of different topics related to graphing. The abbreviated title here is More on Graphing. We're going to start by talking about graphing lines with intercepts, and then we'll get into graphing using slope. We'll talk about vertical and horizontal lines, and then parallel and perpendicular lines. So let's start with intercepts. You should have already heard of y-intercepts. You saw that with y equals mx plus b. So we will be finding y-intercept, and we'll also be finding the x-intercept of a line. So the steps are below, or right on the slide here. Basically, it involves plugging in 0. Okay, so to find the y-intercept of a line, we're going to plug in 0 for x right here. So we'll plug in 0 for x, 5 times 0 minus 2y equals 10. And then we'll simplify. The nice thing is anything times 0 is just 0. So we have this leftover equation right here, negative 2y equals 10. We'll divide by negative 2, and we'll get negative 5. So look how quick that was. We just found 0, negative 5 is a point on this line, and that is the y-intercept. Now we're going to do something very similar and find the x-intercept. So instead of plugging in 0 for x, to find the x-intercept, we'll substitute 0 for y. Okay, so 0 is going to get plugged in for y now. So 5x minus 2 times 0 equals 10. Anything times 0 is 0, so that term cancels out. 2 times 0 is 0. We're left with 5x equals 10. Divide by 5. And x is 2. So when y is 0, x is 2. So these right here are intercepts. And we have enough to graph a line now. All you need is 2 points. So let's go to the next slide. We'll come back to number 2. Let's go to the next slide and plot both of those points. Okay, so we had 0, negative 5 for our y-intercept. So that's down here on the y-axis, 0, negative 5. And then let's see, we got 2, 0. That was our x-intercept. So that's where the line crosses the x-axis. Right here, 2, 0. Okay, now I'd like you to just observe between these two lines, between these 2 points, excuse me, we could find the slope of this line by counting rise over run. Why am I mentioning slope now? Well, it's all related. So let's watch and see, how would I get from this point to that point other than just connecting them? Let's look at rise over run. So if we're counting between these 2 points, kind of making that triangle shape, we're going to count up 5 and over 2. So our slope of our line M is 5 over 2. Why does that matter? Let's find out. So we're going to actually use that to continue adding more points on this line. Okay, so I'm going to connect these two. And instead of trying to draw a straight line and kind of going off and making it curved or something, knowing the slope will help us continue the line in a nice orderly fashion. All right, so the slope kind of gives us directions here. So let's keep going using this same pattern. We're going to go up 5 more, 1, 2, 3, 4, 5, and then over 2. Here's our next point on our line. Let's do that one more time. Up 5 and then over 2. Okay, so we'll just carefully connect those. So this is nice when you're doing it by hand and you don't have a straight edge, and you can see my line's all wobbly here. It's not perfectly straight, but I kind of have these accurately plotted points along the way to guide me. All right, and now to go in the reverse direction, I could just kind of eyeball it and extend the line, but let's use the slope. Instead of going up 5, you could go down 5. You just have to reverse the process and go back 2. So instead of going up 5 and to the right 2, you could go down 5 and to the left 2. It's kind of like if you did negative 5 over a negative 2, right? That's actually the same thing as positive 5 over 2. So that's kind of what we just did. All right, so look at all those points. All right, so I left this third spot in our chart here. You don't necessarily need to fill anything in. Oops, come back. Sorry. You don't necessarily need to fill anything in here. Sorry, there. But it's a good idea to be able to kind of check our work in this way. So let's pick one of the points that we plotted. How about this one here? 4, 5, 4, 5. You can even see the pattern, right, between these points. See how each x coordinate is going up by 2 and each y coordinate is going up by 5. That's not a coincidence, right? But we can check by taking this ordered pair and plugging it into the original equation, which was 5x minus 2y equals 10. So let's take that point. We're really going above and beyond by doing this. You do not need to do this every time, but I wanted to at least show you once. So I'm taking these coordinates and plugging in for x and y, 5 times 4, and then, so I'm replacing x with 4 and y with 5, 2 times 5. 5 times 4 is 20, kind of running out of space here. 5 times 4 is 20, let's see, a little bit of erasing. And then 2 times 5 is 10. And 20 minus 10 is 10. Yeah, that works. So 20 minus 10. We're just verifying that the equation is true. This is a way of kind of double checking. So something that can happen is you can miss a sign. Maybe we would have missed a negative sign here with the y-intercept and put 0, 5. And that would have really thrown off our line. Having a third point to check is sort of, it's what it sounds like. It's a check. It's just a way of verifying that your line is going in the right direction. All right, so we did a little extra work there. The main idea is to find the intercepts. We plug in 0. Now let's go back and do number 2. Okay, this one already looks a little bit different because there's no y, there's f of x. So the first thing I'd like to remind you is anytime you see f of x, that's really the same thing as y. Okay, now I'm actually going to rearrange these terms. I don't necessarily need to do that, but I have y equals mx plus b in my mind, and I'd like us to get in the habit of writing equations in that order. All right, so let's start by plugging in 0. We'll do step 1, find the y-intercept by plugging in 0 for x. So we'll do y equals negative 4x minus 4. So we're replacing x with 0. Negative 4 times 0 is 0. And of course, 0 minus 4 is negative 4. So we just found the y-intercept, which is 0, negative 4. Okay, good. Now I'm a little short on space here, so I am going to switch us over. For some reason, my whiteboard function is not working, so I'm going to take us to paint. I just need a white space to write in. Here we are. All right, so we just found, let's see. We just found that our y-intercept was 0, negative 4. That's our y-intercept. What we're trying to find next is our x-intercept. All right, how are we going to do that? Well, here's our equation, y equals negative 4x minus 4. To find our x-intercept, we're actually going to plug in 0 for y. And then we'll have just a little more work to do to solve for x. So now I have this equation. I'd like to solve for x. I'm getting x by itself. I can add 4 to both sides. So I end up getting 4 equals negative 4x. Then I'll divide by negative 4, and we'll get negative 1 for x. So that's our x-intercept, negative 1, 0. Okay, so we have our x-intercept now as well as our y-intercept. Okay, I'm going to go back so we can fill in our little chart and make our graph using the intercepts. Okay. Okay, and we're back. Okay, so we got 0, negative 4, and then we got negative 1, 0. So let us fill in our little chart. I'll just use red, that's fine. So let's see, 0, negative 4 was our y-intercept. Down here on the y-axis, that's 0, negative 4. And then we also had our x-intercept, which was -1, 0. And that's over here on the x-axis, -1, 0. All right, good. And I hope you can start to see, if you're reading this line from left to right, we're actually going down. So our slope for this line, slope or m, we're going, man, sorry, keep doing that. We're going down 4 over 1. So our slope is -4 over 1. It's really -4, but I'd like to leave it over 1 right now. So we can kind of use that to count rise over run and quickly add some more points on our line. So let's do that. Okay, so down 4 over 1. Let's use that slope to keep going. We're going to go down 4 over 1, like that. And now to reverse the process, I'm going to sort of go backwards. I will go up 4. I'm just going to go to the left one instead. Okay, or you can just take out a straight edge. But you're going to be graphing on the computer, aren't you? So maybe you don't care about straight lines because it's just going to happen. All right, and then just like last time, you can add a third point just to kind of double check. Looks like the next point that we had done was right here, 1, -8. Or you could do -2, 4, or -3, 8. Any one of those would be fine. Maybe I'll just do 1 and then -8. So we'll just quickly check that one. Check. We're just going to make sure that that point does fit in our original equation. So our original equation was f of x equals -4 minus 4x. Okay, instead of f of x, we'll replace that with the y coordinate, which is -8. And then our x coordinate is 1, so -4 times 1. And we're just verifying that this is correct. Okay, I'm being a little glitchy here. I'm sorry for all the switching back and forth between the slides. I might be writing too hard. All right, I think we can agree that this equation is true. So -8 on the left, and then over here on the right side, -4 times 1 is -4. -4 minus 4 is in fact -8. So let's see if we can write that. Yeah, it works out. Okay, so the main idea there, without all the extra checking, the main idea is when you're graphing using intercepts, it's important to plug in 0. Okay, I think I am going to be going back and forth between our notes and then just a quick example in MyLabs Plus. So I'm going to quickly take you over to show you maybe 1 or 2 problems where we have to use intercepts to graph. So that's kind of what the first section of your homework 35 will be. So that's what I'm taking you to right now. Okay, here we are, I think. And as we've seen before, the very first question, it has 12 parts. All right, so this is kind of walking us through what we have just gone over here. Let me just maximize this screen for us. Okay, so find the intercepts and then graph the line. So it's really going to make us kind of break it down. So what did we just learn? First, find the y-intercept. So what do we need to do to find the y-intercept? That's where we plug in 0 for x. So that's this first choice. Okay. Okay, so it's going to walk us through that. So we're plugging in 0 for x here. Yep, anything times 0 is 0. Then we'll solve for y. So the next thing we'll have to do is add 18 to both sides and divide by 9. So what's the next step? We're going to isolate the y term on the left side of the equation. Okay, so we're adding 18 to both sides. Then we'll divide by 9 and get 18 divided by 9, which is 2. Okay, so we just found the y-intercept. Now, if you just type 2, I don't think it's going to accept it. See, your answer must be in the form of an ordered pair. So try to remember to do that. Type an ordered pair. 0, 2 is what we want. Okay, now we're going to do it again for the x-intercept. So to find the x-intercept, then we plug in 0 for y. So whichever intercept you're finding, plug in 0 for the other one. Okay, so we're going to do that. Plugging in 0 for y. Negative 18 is what's left. Now we'll divide both sides by negative 6, and we're going to get positive 3 for x. So our x-intercept, remember, it's not just a number, and it's also not 0, 3. This time it's 3, 0, right? So 3 is x. Remember, we plugged in 0 for y. So be careful about your ordered pairs, about your order. Okay, are we ready to graph? Finally. Okay, so these are the points we're going to plot. So we'll go pick our line tool that we've done many times. And I'm going to start with the y-intercept. 0, 2 is right here on the y-axis. And now I'm going to find my x-intercept, which is 3, 0 over here on the x-axis. So you can see my two blue points that are highlighted here. These are the intercepts that we're looking for. And there we go. Okay, so that's what it looks like to graph using intercepts. Question number 1, that was 12 steps that we had to go through. I'm going to skip that one for now. Okay, here's another one using intercepts to graph the equation. So we can quickly do this one if we want to. We're plugging in 0 for each variable. So maybe I'll start by plugging in 0 for x. And I just get negative 6 for y. So 0, negative 6. So eventually I'm going to plot my point there. And then I'll do the same thing to find the x-intercept. X minus 6 equals, now I'll plug in 0 for y. So I'll just have to add 6 to both sides. So it looks like my x-intercept is 6, 0. That's over here on the x-axis. So those are the 2 points that I'll be plotting. Okay, so I just kind of drew them on here, but of course what we'll do is we'll have to actually graph. So I'll use my line tool. I'll click on the y-intercept here at 0, negative 6, and then I'll click on the x-intercept here at 6, 0, and check answer. Okay, good. I think we're okay there. We will be learning another method of graphing in a minute. We'll get back to y equals mx plus b. Let me just show you something to look out for. So I just did similar question here. What you might find yourself doing at some point is you're going to see y equals mx plus b so much that you might get a little carried away and not read directions. So in this problem, if I were to rearrange it, y equals x minus 4, what you might do is, okay, I'm going to start at the y-intercept of negative 4, and then my slope is 1, so I'll go up 1 over 1. It's going to be marked wrong, unfortunately, even though your line would technically be right. So watch what happens if you do it that way. Starting at negative 4, I'll use my slope up 1 over 1. Now see how I did not click on the x-intercept? It specifically says use the intercepts, and I did not do that. So my line, my yellow line here is great, it's perfect, but watch what happens. It says you graphed the correct line, but didn't use the intercepts to draw it. So, I mean, I did something good, I just didn't follow the directions. I really need to do the process of plugging in 0. So actually this, if I just drag it up, that's the point that we want to get. When we plug in 0 for y, we would get x equals 4. So that's the intercept. So you can see it's probably a little frustrating if that happens. The line is still the same, but you have to actually click on the intercepts. Okay, let's go back to our notes now. Okay, so we know about graphing using intercepts. Okay. And now we're going to do what I just kind of gave you a preview of. We're going to graph using the slope and y-intercept. And this is the more common method. And it's really important to learn this, but I want to just have you keep in mind what we just did. If the directions say to graph using the intercepts, make sure you do that. Okay, so read the directions, I guess, is my point here. All right, so graph a line using slope and y-intercept. So what does that mean? Well, we're going to use y equals mx plus b. Okay, and our slope is m. We've seen this before. So our slope is m. And then our y-intercept is going to be 0b. All right, so let's see what this looks like for these two examples here. Okay, so let's start with number 1. Y equals mx plus b. So m is 5/4. So we're going to be going up 5/4, but we need a starting point first, which is right here. Our y-intercept is going to be 0, -3. So let's start there on the graph, 0, -3. Okay, now I'm going to use the slope to count. I'm going to go up 5/4. When we say over 4, or when we say over, we mean to the right. Okay, so we're going from left to right. I know sometimes I kind of go backwards. I'm going to call it backwards rather than calling it left. So just assume we're always going to the right unless you're running out of room. Remember, we learned about those different kinds of slope. This is positive slope, so we expect our line to go up from left to right. Okay, so let's do it. So we're starting at the y-intercept, and we're going to count 1, 2, 3, 4, 5. I went up 5 and then over 4. 1, 2, 3, 4. Here's my second point. That's all you need. Okay, so on the homework, on MyLabs Plus, or on a test, you would just click on those 2 points and then your line would be drawn for you. I'm going to add another point and continue. I'm going to go up 5 again. 1, 2, 3, 4, 5, and then over 4 again. 1, 2, 3, 4. Okay, and I could keep going literally forever, but I'm out of space on my graph paper. So there we go. And then I could kind of just extend my line here, but if I have room to do it, if I move my little toolbar out of the way, I can count in the reverse direction. Instead of going up 5, I could go down 5. 1, 2, 3, 4, 5. And then you can see you're not going to go over here and make a weird zigzag. That's not happening. So you know you need to reverse the process. Rather than going up and to the right, we will go down 1, 2, 3, 4, 5, and then over 4 to the left. 1, 2, 3, and 4. There we go. So that's number 1. Now I put number 1 and 2 together to save paper back when I was printing paper and handing that out in person, but we are writing on a screen right now and it's getting pretty messy. So what I will ask you to do is make sure you have everything down for this. For number 1, I'm going to clear my screen so that you can more easily see number 2. You might be writing it all on one little graph area or taking notes in another way. So now's your chance, or you can rewind if you miss it. I'm about to clear number 1 so we can focus on number 2. So clear. All right. Maybe. I'll just erase. Erase. All right, making some room because it's just gonna get messy. I mean, I could use different colors, but even so. So take a look at number 2. Notice again, there's that f of x. We've seen that many times. F of x is just y. So we'll look at number 2 now. Feel free to rewrite it. Y equals, instead of f of x equals, it's the same thing as just y equals. There you go. So now it looks familiar, right? Now it looks like y equals mx plus b. For this one, our y-intercept is 1, or we will be more specific and say 0, 1. Oops. So that's our y-intercept. That's b. And then this time our slope is -2/3. So we'll be going down instead of up, down 2. We'll still go over to the right. So with negative slope, we will expect our line to be going in that down direction from left to right. So here's 0, 1. That's our starting point. That's our beginning point, 0, 1. Okay, and now, so that's our y-intercept. Now we will use the slope to go down 2 over 3. Now look at when I rewrote this fraction, just pure habit. I can't help but put the negative sign in the numerator. I'd like you to think of it as being in the numerator. I know it's off to the side. You could put it in the denominator or the numerator, not both. But think of it as the numerator. That'll remind you to go down. So remember, rise over run. Our rise is -2, so we're going down 2, and we'll still go over 3 to the right. So let's do that. Down 2, and then 1, 2, 3, like that. I'm going to do it again because I have room. Down 2, over 3. Down 2, over 3. There we go. So this is my line. You can see it's going down, has that negative slope. Look at all this empty space to the left though. Let's try to fill that in. Just like last time, we'll reverse the process. Instead of going down 2 and making a triangle, not doing that, we will go up 2, but let's just go to the left 3. So let's sort of back it up. So instead of down 2 over 3, we'll go up 2 and to the left 3. So again, down 2 over 3 is what we did before. Now we'll go up 2, back 3, up 2, back 3, up 2, back 3. You're just kind of continuing the pattern. Okay, take comfort in the fact that we're only graphing lines here, and we're not graphing parabolas or curves or circles or anything like that, just lines. So if you have anything that looks not like a line, that's your clue to stop and make a correction. You should only be graphing lines right now. Okay, so that's number 1 and 2 here, graphing a line using slope and y-intercept. I will just show you on the homework where you'll start to see that instruction. So here we are back at homework 35. Let's see, we had done, this was number 3, I believe. So let's look ahead a little bit. You have quite a few problems that will say use the intercepts. We want to look ahead until we see the word slope. So it's still saying find the intercept. So for now we're in number 6, we'd still be plugging in 0. Find the intercepts, number 7 still. Use the intercepts. Oh yeah, I had started this one. And see, I did it using the slope and I got it wrong. Yes, I know. Find the intercepts. There we go. Okay, so number 10 on your homework 35, this is the first one that's going to ask you to graph using the slope and the y-intercept. So take a look at this one. It's already in that slope-intercept form. Y equals mx plus b. M is 8/3, b is 7, so you'll start at 0, 7, and then we'll go up 8 over 3. All right. All right, so let's go ahead and graph this line. So we will be starting at the y-intercept of 0, 7. Oh, and we're counting by 2s here, so let's be careful. I'm going to close this. Yeah, I'm going to follow my coordinates here. This is 0, 8. This is 0, 6, so 0, 7 right here. And then I'm going to count up 8 over 3. That's going to be a little annoying. But if I'm starting at 7, if I go up 8, I should end up at 15, because 7 plus 8 is 15. And then I'm going to go over 3. So I should end up at 3, 2, 3, at 3, and then 15 for my new point. Okay, so just to recap, graph the equation using slope and y-intercept. Our y-intercept b is 7, so we started at 0, 7. Our slope is positive 8/3, so we went up 8 over 3. And I'd keep going if I had room, but even if I did have room, actually, I couldn't click a third time. You've seen a few times already now to graph lines on MyLabs Plus, you really just can click on these 2 points. So let's check this answer. Okay, good. All right, and then you'll see some other versions of this. Here's another quick one. This is f of x instead of y, but we're okay with that. Y equals negative 8/7 x minus 3. So this time we'll start at 0, negative 3, and then we'll be going down instead of up. So down 8 over 7 to the right. Okay, so let's do this graph, then we'll get back to our notes. Okay, so 0, negative 3, right here, maybe. I gotta click on my line tool again. Let's see. There it is, sorry about that. Okay, so 0, -3, and then I'll go down 8. So -3 minus 8 would be -11, and then over 7. Okay, and there's that negative slope we're looking for. All right, good. And then the other equations coming up, you'll have to do maybe a little more work to solve for y. So you want to get that y by itself before finding the slope and the y-intercept, etc. Okay, let's go back to our notes here. We're doing a little more back and forth today, but I do want you to see the connection between everything we do here and what you're being asked to do on the homework. All right, I'm gonna switch my screen back so you're with me. Okay, good, okay, perfect, here we are. So speaking of which, solving for y, that's exactly what we need to do for this next equation. Okay, so x plus 3y equals 12. We need to rewrite this in slope-intercept form. So we need to solve for y. So let's get that y by itself. I'm subtracting x on both sides. 3y equals -x plus 12. Now we'll divide everything by 3 to get the y by itself. So we end up having y equals, now instead of -x over 3, I'm going to write -1/3 x, and then 12 divided by 3 is 4. So here's my equation. I rewrote it that way so we could easily see the slope, which is right here. So our slope is -1/3, which means we'll be going down 1 over 3. Our y-intercept is 4, but we're going to write it as an ordered pair, 0, 4. All right, so that's enough to make our graph. So let's start at 0, 4 on the y-axis, 0, 4. And we're going to use our slope to count down 1 over 3. And we'll just keep doing that, down 1 over 3, down 1 over 3, down 1 over, and I'm out of room here, but I do want you to know, remember we found intercepts earlier? If we had found the intercepts by plugging in 0, if you had plugged in 0 for y, our x-intercept would be 12. So I kind of wanted you to see that, but we didn't have quite enough room. All right, so sometimes either method will work, okay? So we're just trying to follow the directions given to us. So we graphed using the slope and the y-intercept. I really should extend my line the other way. Instead of going down 1 over 3, I'll go up 1 and to the left 3. Just change the color on that. Up 1 and then 1, 2, 3, up 1 and back 3, up 1 and back 3. There we go. So again, by going in that reverse direction, it's kind of like instead of my slope being -1 over 3, I'm saying it's 1 over -3. It's the same thing. So you could go up 1 and then left 3. That's what I was doing here. All right. But generally, I'd like you to think of the negative as being in the numerator to remind you to go down. Okay, good. Okay, so the next drawings that we're going to see, the next graphs we're going to see, are these two unique kinds of lines, vertical and horizontal. We've talked about these already, actually, when we talked about slope. So this should be a little bit of review. Okay, so let's see if we can remember which is which. So here's our first equation, x equals -6. Okay, when people are asked to graph x equals -6, here's what often happens. A student will look at the x-axis and find -6 and then not know what to do and say, okay, I have a point, but what am I supposed to do now? And sometimes I'll see lines going like this, no, that's not it. Okay, so no. So what do we do instead? Well, I've made this chart for you here, and you can make one yourself. I mean, you could extend this the idea is it does not even matter what y is as long as the x coordinate is -6. So yeah, one of the points on the line is over here at -6, 0. That's this one. That's the x-intercept. We just need at least one more point, and maybe 2 or 3 more points. -6, maybe -1, -6, 1, -6, 2, -6, 3. Whoop. Sorry, I have a pop-up here I'd like to get rid of. Okay. Yeah, so you can see the shape of this line. It's turning into a vertical line. Okay, so whenever you have x equals, your line will cross the x-axis, and it is vertical, and the slope is undefined. So just a reminder about that, undefined. Okay, now the second example here with y equals, kind of the opposite. Okay, this time all the y coordinates are 8, so x can be whatever. So usually what students do is they find the y-axis and then they go to 8 and then they forget what to do. But now you know what to do. We're going to cross the y-axis and not the x-axis. So if we're never going to cross the x-axis, we need to have a line that's parallel to the x-axis like this. Okay, so using the table here, -1, 8 would be another point. 0, 8 right here on the axis, 1, 8, 2, 8, 3, 8, etc. As many points as you need to remind you of the shape here. So this line crossing the y-axis is horizontal, and this line has a slope that is 0. Okay, so just some reminders about slope there. Let's see if we can find a homework problem related to this. Okay, it should be a nice, quick, easy problem, but I get questions on these all the time. So I want to make sure you're ready for it. Here we go. So this is number 15 on homework 35. Let's make sure we're sharing the right screen so you can see this. Yes, you can. That's great. Okay, so x equals 5. So I have my line tool. Here's the x-axis. I'm finding 5. Oh, just kidding. Clear. I didn't find it. Try again. 5. There it is. All right. Here's what not to do. It's not this. I just see this all the time. This is y equals 0. That has nothing to do with x equals 5. You have to go through the x-axis. So reminder, make yourself a table here. I'm going to just leave this for a second and just make you a little chart just like we did before. Oops. Okay, so all you need are 2 points, and they both need to have x being 5. So how about 5, 0? We got that already. Let's do one more. How about 5, 1? Okay, so that'll be my next point on my line. Here's 5, 0. Here's 5, 1. Got it. So there's my vertical line. Okay, so let's check that answer. Maybe. Okay, sorry, too many toolbars. It was covering up the blue button. Check answer. Got it. Okay, one part remaining. Now, what is my slope? We just talked about this. This is a vertical line. The slope is undefined. Now, it looks like we'll have to choose choice B for the slope is not defined. That's literally what the word undefined means. Okay, good. So we'll check answer there. Great. So that was number 15. Number 16 is very similar. Instead of x equals, it'll be y equals. So this one, y equals 4, going to the y-axis at 4. And then you know it's going to be a horizontal line like that. And if you want to make a little chart again, that's fine. Here's what it would look like. This time, your points both need to have y equals 4. So how about 0, 4 or 1, 4? It looks like I did 5, 4. It does not matter as long as I'm creating this horizontal line. Good. And then are we going to get asked for the slope? Let's find out. Yes, our slope is, now we just went up 0 over 5. Our slope is 0. Now, if I put 0 over 5, I don't think it'll accept that. No. Our slope is just 0. Good. Okay. So when you see those x equals and y equals problems, now you know what to do. This one right here, f of x equals, remember, f of x is the same thing as y. So this is really the same thing as y equals 5. Okay, so make a little chart again if you need it. A couple points with y equals 5. How about 0, 5, and 1, 5? And that should be enough to make your line. So again, when you see f of x, it's just y. So 0, 5, 1, 5. Okay, and just like the previous problem, the slope is 0 for this one. Good, and here's another one. Okay, let's go back and see what else we have to look at here. Okay, so we talked about vertical and horizontal lines. Let's move on. Okay, finally, here we are. So the last big topic here in this section on graphing is parallel and perpendicular lines. So now we're comparing two lines at a time. You may remember learning the word parallel maybe a long time ago, and you might have learned that parallel lines never cross. That is true. What I need you to know now is the reason they never cross is because their slopes are the same. So parallel lines are going in the same direction. And the reason why they're going in the same direction is they have the same slope. So take a look at these two lines here. Both of them have a slope that is positive. You can see them going up from left to right. Let's just check that out between these two here. Here's this red line. Looks like we're going up 1 over 2. Same thing with this kind of gray line here. Up 1 over 2. So both of them have a slope that is 1 over 2 or 1/2. They have the same slope. Now, perpendicular lines do not have the same slope. These lines form a 90-degree angle, a right angle. Now, we're not talking about angles in this class, really. So again, it comes back to slope. Their slopes are opposite reciprocals. Okay, opposite means you're changing from positive to negative. Reciprocal, you might think of flipping a fraction. So let's take a look at the slopes of these lines. This gray line here, we are going up 1 over 2. That line has a slope of 1/2, up 1 over 2. Take a look at the red line though. Let's pick these 2 points. If we count rise over run, we're going down 2 over 1. So -2 over 1. I know we could reduce that to -2, but let's leave it for now. I want you to see the connection here. One line has a slope that's positive, the other line has a slope that's negative, and they are reciprocals of each other. So negative reciprocals or opposite reciprocals. That's the relationship for perpendicular lines. Now again, I have this feeling that maybe when you were very young, maybe in elementary school, some teacher told you that perpendicular lines cross each other and parallel lines don't. That is true. However, it's a little more than that. It's not just lines that cross each other. They cross each other in a very specific way. And the slopes have to have this special relationship. If you just draw two random lines that cross each other, those are not perpendicular. So no, they have to have this kind of right angle relationship here or sort of form like a corner. But again, it's going to come back to slope. Compare the slopes, they should have opposite signs and they should be reciprocals. The one exception to that is vertical and horizontal lines. Those are automatically perpendicular. One line has a slope that's 0. That's the horizontal line. I mean, the negative reciprocal or opposite reciprocal would be -1 over 0, but what is that? That's not anything. That is undefined. So we don't say that, we just say undefined. So M would be undefined. for this vertical line. Okay, so just to recap, parallel lines never cross because they have the same slope. Perpendicular lines, they do cross at a right angle, and their slopes are opposite reciprocals of each other. Okay, so let's see what our next question is asking us. Checking my notes here. Yeah, all right, we've made it to the last problem. This is great. Okay, so we are going to determine whether these two lines are parallel, perpendicular, or neither. Now, neither would be just two random lines that are crossing in no special way. They're just crossing, but they're not perpendicular to each other. So I don't recall seeing that option very much on your homework. So let's just focus on whether they're parallel or perpendicular, and we'll kind of take it from there. So how are we supposed to know that? We have no picture to look at. What we're going to do is rewrite each equation in slope-intercept form so we can compare the slopes. So let's do that. All right, now this first equation, it's pretty much already in slope-intercept form. If I just put the y on the other side, y equals 2x plus 4. That's the same thing as 2x plus 4 equals y. Okay, so this line has a slope of 2. Okay, because that's the important part that we're looking at right now. Now let's take a look at our second equation. It's not in slope-intercept form. We need to solve for y. So let's divide everything by 8. Y equals, right here, the negative 4x over 8. We really need to focus on the negative 4 over 8. We can reduce by dividing by 4. We'll get negative 1/2 x and then minus 7/8. Don't worry, we're not graphing this, so don't worry about this 7/8. It's not really relevant to this question. What's relevant and important are the slopes. Okay, so let's compare these slopes. I hope you can see they are obviously not equal to each other. So are the lines parallel? Absolutely not. So we would definitely not choose that they're parallel. No, that's only if the slopes are the same. So now we have to ask, are they perpendicular? Well, are these numbers opposite reciprocals of each other? They are opposites. They do have opposite signs, one positive, one negative. And if you put the 2 over 1, then you'll see, yes, they are, in fact, not only opposites, but they are opposite reciprocals. So we get to choose choice B. So yes, they are perpendicular because their slopes are opposite reciprocals. Now, I did want you to see a quick visual of this graph, if I can find it. Let's see. Okay, so I did graph these ahead of time. I want to make sure you can see this. I just wanted you to see, kind of prove it to ourselves that yes, these lines do appear to be perpendicular. Now, we can't trust our eyes on this, but I hope you can see between these two lines, they're crossing each other, and not only that, they're crossing each other at what appears to be a right angle. So you can kind of see that corner here. So one line is going up, positive slope. That's the one with the positive 2 over 1. And then this other line is going down, down 1 over 2. That's negative. And that slope was negative 1 over 2. Okay, so anyway, I just wanted you to have that quick visual. I just used a little graphing calculator for that. All right, very good. So we have seen all the basic topics here in this lesson. Let's take one last look at our homework and see if there's anything that we may have missed or need to see a little bit more of. So I'm back one last time at homework 35. Okay. Okay, all right, number 19 I had actually done ahead of time. So here's another one about parallel and perpendicular. Determine whether the graphs of the pair of lines are parallel. So for this question, I did answer it already. Y is already by itself in that first equation. So it's y equals x plus 7. It's really 1x plus 7. So the slope was 1. And then with the second equation, if I just add x to both sides, y equals x minus 3, and there's that 1x again. So that line also has a slope of 1. Because the slopes are the same, then are the graphs of the given equation parallel? I said yes, because the slopes are the same slope. Okay, so that was number 19. Let's see if we can find another one asking us about parallel and perpendicular. Okay, so parallel. I want to find a slightly harder one if we can. Oh, sure, how about this one? Number 22. Determine whether the graphs of the given pair of lines are parallel. This is a weird one because there's not even any y in the equation, it's just x. So I guess I'll solve for x. That seems like the logical thing. 11x equals 7. If I just divide by 11, x equals 7 over 11. Okay, great. How about this other one? Negative 5x equals 2. Divide by negative 5. X equals negative 2 over 5. Okay. Here's the thing with this one. We've been trained to look at slopes, and if you're looking at these fractions as slopes, they're not the same, and they're also not opposite reciprocals. So it kind of feels like they're not parallel or perpendicular, but I'd like to remind you that the important thing here is both of these equations have x equals. Both of these are vertical lines. One of them, x equals 7/11. Where is 7/11? I don't know, somewhere between 0 and 1. Here. X equals 7/11, something like that. And then where is x equals negative 2/5? I don't know, somewhere between 0 and negative 1, like that. The point is they're both vertical. Okay, so if both of these lines are vertical, yeah, they are parallel. So are the graphs parallel? Yes. Strangely enough, they are. They have undefined slopes. So the fractions kind of have nothing to do with it. So that was definitely a strange one. Okay, let's see. Let's look at one more here. This is number 23. Determine whether the graphs of the two equations are perpendicular. So the way we're going to do that is compare the slopes. This first equation, I can already tell y equals mx plus b. The slope is 4. Let's look at the second equation. 2y equals 7 minus x. I'm going to rewrite it as negative x plus 7. If I divide everything by 2, solving for y equals, this is negative 1/2 x plus 7 over 2. Okay, so let's compare the slopes. The first line has a slope of 4. The second line has a slope of negative 1/2. So let's answer the question. Determine whether the graphs are perpendicular. So perpendicular would mean the slopes would be opposite reciprocals. The opposite reciprocal of 4 would be negative 1/4. That is not what we're getting. So no, these lines are not parallel, but they're also not perpendicular. So are the graphs perpendicular? No. This would be a neither situation. They're not parallel or perpendicular. There's nothing special about 4 and negative 1/2. They're not the same, but they're also not opposite reciprocals. All right. Good. And then I think the remaining questions have to do with just some more work solving for y and comparing those slopes. Okay, let's end on this last one. This is number 26. This is another problem that involves just one variable at a time. Okay, so with this first equation, if I solve for x, I would get x equals 4/5, dividing by 5 on both sides. With the second equation, if I solve for y, divide by negative 3, 9 divided by negative 3 is negative 3. Once again, the numbers are not important here. What's important is that you recognize what kinds of equations you're dealing with. This is a horizontal line, y equals something is horizontal. And then the other line, x equals, that's definitely a vertical line. So yeah, they definitely are perpendicular. The numbers really have nothing to do with it. It's a horizontal line and a vertical line. So yes, those lines are perpendicular. Okay, so there's a lot going on in this section. This might have been a little bit on the longer side, and there's kind of a mixed bag of different topics that happened here. So as I always say, please ask for help if you're feeling confused and you need more clarification on something, and I will do my best to answer your question either with an email, or sometimes I even send little mini videos if you ask for that, or I'll give you a call, or whatever I can do to help you kind of get the hang of all of this. Okay. All right. So that was homework 35. We also saw the lesson 35 notes all in one big giant video. So as always, thanks for making it to the end, and hang in there. Thank you. Bye.